Our next subtopic of discussion is electrolysis. Recall in Form 2 chemistry, we discussed electrolysis of molten substances. We talked about electrolysis of molten substances. Here we are going to discuss electrolysis of aqueous solution. So we'll discuss aqueous substances. That is what will create the difference between the electrolysis discussed here and the one in the Form 2 chemistry. When an electric current is passed through an electrolyte, a chemical change takes place, and this is called electrolysis. The apparatus used for electrolysis is called an electrolytic cell. That is apparatus used, or what we call electrolysis cell. So it is the water that will make the substance now be aqueous, which means that water also brings in some of the ions. Like if you recall the Form 2 electrolysis, if you talk about molten lead 2 chloride, it only has molten lead ions and chloride ions. But in a case where you now mention aqueous copper 2 sulfate, it means there is water and copper 2 sulfate. So the ions present include, we are talking about in aqueous copper 2 sulfate will have copper ions, sulfate ions. That is from the side of copper 2 sulfate. But remember, it is aqueous. Water is added. So other ions include hydrogen ion and hydroxyl ion from the water. So this is what we want to discuss in this subtopic. Let's mention some of the factors affecting the discharge of ions. Factors affecting discharge of ions. The first common factor is the position of the metal in the electrochemical series. Position of the element, or we just talk about position in the electrochemical series. That is one factor, of which if you compare the discharge of For example, copper and hydrogen, you realize that copper is preferentially discharged to hydrogen because of its position in the electrochemical series. It is lower than hydrogen in the electrochemical series. So that is to say, if we have the series potassium, calcium, sodium, magnesium, aluminium, zinc, iron, tin, hydrogen, copper, silver. That is for the metals. This is increasing ease of discharge. So this is the side for most easily discharged. Takes very small amount of energy to be discharged. These ones, the other side, least easily discharged. The lower the substance is in electrochemical series, the easy that substance is discharged. So realize that if you compare copper and hydrogen, copper 2 ions are preferentially discharged to hydrogen ion. If you look at zinc and sodium, then it is clear that zinc ions are preferentially discharged to sodium ion. That is discharge at the cathode, where we have the metals. That is normally the discharge at the cathode. Let's look at the case for an ions. The discharge at the anode. Anode discharge. So there is iodine, chloride, nitrate, sulfate. Ease for discharge. Increasing ease of discharge. This side is the side for least easily discharged, most easily discharged. So remember, if you compare hydroxyl ion and sulfate ion, then the hydroxyl ion are preferentially discharged to sulfate ion. So that is the position of the ion in the electrochemical series, and we've seen what will control the discharge. However, there is another factor known as concentration that may go against the first factor of the position. So number 2, second factor is concentration. So the influence by concentration in the solution, for example, in concentrated sodium chloride, the chloride ions will be discharged. The chloride ions will be discharged in preference to hydroxyl ions. Although in the electrochemical series, the hydroxyl is easy to discharge than chloride. So it is the concentration of chloride ions that are more than hydroxyl ions here. And that is why the chloride ions get discharged in preference to hydroxyl ion. However, when you talk about dilute sodium chloride, for dilute sodium chloride, then it is clear that hydroxyl ions are preferentially discharged because the concentration now does not make the chloride ions to be discharged. It is dilute solution. Hydroxyl ion preferentially discharged. So that is the role of concentration in the discharge of ions. Nature of electrons. The last factor is nature of electrons. If the energy required from the metal to dissolve into solution as hydrated salt is lower than the energy required for the deposition of the hydrated ions at the electrode, then the metal will dissolve into the solution. And we're going to look at that later in this topic when we'll be talking about the applications of electrolysis, where we'll see the nature of electrode coming out clearly.